Hello, and welcome to another episode of Adventures in .NET. I'm Sean Clabo, your host, and with me today on the panel are Wai Lu.
Hello.
Hi, Wai.
How you doing?
Good. And we also have Wade Gosden.
Hey, how's it going?
Yeah. And the topic today is going to be F# and our special guest, Phillip Carter.
Hello.
Hello, Phillip.
A few years ago at a JavaScript conference, I was approached by Nader Dabit, and you might know him for the React Native Radio podcast. He's also a developer evangelist for Amazon. And when he came to me, we had a conversation about React Native. And the thing that I love about React Native is that it's approachable, it's web technology, and it's cross-platform. And it makes a lot of things really easy for developers to jump in and do interesting things on mobile with JavaScript. So we've had this show now running for several years, React Native Radio, where we interview people about the React Native ecosystem, some of the things that are coming out in React and how they affect mobile, and other options that you have for mobile development. So if you're doing mobile development, you're doing it in JavaScript, you're looking for a good option, or maybe you're just trying to stay current with React Native, then go check out React Native Radio at reactnativeradio.com.
So why don't you tell us a little bit about yourself, what you do, where you work, what kind of things you like to do?
Yeah, so I work on the .NET team at Microsoft. So like the same team that does C#, Visual Studio tooling for .NET, and also F# and F# tooling for Visual Studio, that sort of stuff. So like my primary focus area is F# and F# tooling, F# language design, but I also do a lot of like just sort of general .NET team stuff like .NET project integration tooling in Visual Studio, some of the recent stuff that we've been doing with .NET Core, things like that. So kind of wear a lot of different hats with like a major focus area being core F# language.
Okay. You based out of Redmond or?
Yeah.
Okay. Nice. Yeah, it's not too far from me, just the other side of the state. So good. No snow on your side yet, but there's snow over here.
Hopefully there's some snow because I'm looking forward to ski season. I already got my season ticket. So.
Oh, nice. Yeah. Where should we get started about F#? You know, I'm familiar with it a little bit, but not anything in depth. So what's the first thing someone should know about F#?
The best way to describe it is like it comes with a prerequisite of like knowing what functional programming is. Maybe not necessarily being an expert in functional programming, but like if you heard about functional programming and you want to use .NET and especially .NET Core, well, F# is sort of like the functional programming language for .NET Core. That's kind of the main pitch that we have. So we got C#, which is like modern object-oriented language, and then we got F# is like modern functional language, all for .NET Core. And that's kind of like the main like pitch, I guess I would give. And like in terms of what that actually means beyond just, you know, knowing that it's a functional language, it sort of implies like a very different way of writing your code in .NET. And so you can still interact with like your same set of core libraries and still use the same NuGet ecosystem and use Visual Studio tooling, connect to Azure, connect to different, you know, environments that .NET has full support for. But you do it in a way where the code that you write is like everything is immutable. Your code typically looks very, very different from your C# code, and kind of the way that you approach your problems is about functional programming rather than like modeling things with objects and, you know, trying to figure out how to have these objects talk to each other and things like that. So it's sort of like, you know, if you want to do functional programming, but you want to get access to a large ecosystem and get full support on a variety of different platforms, then you can do that. You don't have to, you know, dive into functional programming, but also give up, you know, that kind of good quality like library support that you need when you want to build something, especially for production apps.
So are they fully like C# and F# like fully interoperable? Like could you say like be using F# and then use a NuGet package that's been written in C# or
yeah.
Is that generally how it works? So you would only use F# for a particular part of your program, or would you use it for the whole program? Or would it depend?
That's a good question. A lot of F# professional F# developers kind of have a variety of different ways of doing it. Some people are like all in on the do it all in F# sort of thing, right? Like, you know, from soup to nuts, F# all the way. And maybe you consume some NuGet packages that were written in C#, which you can do, right? Because it's just .NET. And so the F# compiler knows how to read the fact that, you know, it's a .NET binary. So it reads the IL that the C# compiler generates and turns it into constructs that, you know, F# can understand. But a lot of people do mix and match C# and F# within their own code bases. So beyond just being able to consume like a package, you can actually have projects referencing each other. So you might do something like, integrate, as an example, something that I did in the past was we had a really huge like WinForms app that connected to a whole bunch of different legacy services. And we were, adding a whole bunch of new stuff to it as well. The users of this app wanted to have like a DSL because they're sort of like power users. So there was like a little text box that was going to just have like, some basic commands that they could enter, and that would get translated into like real actions. And depending on what they did, it'd read something from the database, or it'd write something to the database, or communicate to different databases that we had and things like that. And so we actually wrote that component in F# just for like the parsing of the DSL into, concrete object types that actually already existed in C#. And so sort of like a mapping between the text and the existing domain that we had written in C# already. And it was pretty straightforward. When you write F# code that, you want to consume in the C# world, you sort of have two major options. You can consume an F# function from C# like directly. It represents itself as a static method. So it's just like calling a regular static method in C#. Or you can actually construct an object like an object interface or an interface type that like, you consume from the C# side, and then there's like an object backing it in F#, and that itself calls into a whole bunch of functional stuff, so that you can have like this functional kernel that you write in F# and then expose it in ways that are like really nice for C# programmers to use. Out in the wild, people tend to do either. Like, there's not, I don't really have a good feel for if people go all the way with F#, like how many people go all the way with F# versus how many people mix and match like that. But because you have the flexibility to do that, I think there's a good variety.
And you sort of mentioned out in the wild. Are there some sort of big popular apps out there in the public that are built in F# that you know of? Yeah,
I'd say the biggest, I guess it's not really an app so much as a backend system. Or Jet.com, or like, Walmart e-commerce as their, or Walmart, like the big Walmart e-commerce conglomerate, and Jet, like, the big multiple companies, multiple brands sort of thing. But they built their entire backend suite of microservices in F#, about 300 or 400 of them. Like the apps themselves, like when you actually interact with the website, it's just kind of standard JavaScript on the website. Their mobile apps are like, standard Swift, Android, that sort of stuff. But depending on how they connect to the backend, they either connect directly to an F# microservice, or they connect to, at least for a while, they had like a little Node.js, like little entry point that would just, take a request and route it to a particular microservice, depending on what the action was. They're probably one of the biggest. And another one, I guess maybe people don't use it as an app that much, but if you bank with Credit Suisse, you're like, anything that you're doing is probably running on F# code at some point. A lot of other financial institutions have F# kind of running in the back end, like for their calculation engines. So I don't know if there's like an app per se, but like a lot of back end systems that do a lot of the sort of calculation work, or, interacting with like, streams of events or that sort of stuff. A lot of that's usually done with F# when people are using F#. So
it's interesting you mentioned Jet and Walmart, because obviously F#, I think traditionally has been seen as sort of financial institutions, maybe scientific, sort of number crunching sort of thing. Is there an industry that you sort of see F# growing, maybe that you didn't expect it, or just an industry where F# is getting used more and more outside of sort of that number crunching, or is it mainly used for that?
I think prior to .NET Core 2.0, it was definitely like more in the financial calculation engine space. Like, I mean, there were plenty of people using F# as a general purpose language, but I don't think it really had like, I mean, prior to .NET Core 2.0, realistically, most .NET was still done on Windows. And there was all this great like tooling for doing Windows apps, and, all the classic ASP.NET support was all sort of assuming C#. And I think that was sort of where F# was kind of pigeonholed for a while. Ever since .NET Core 2 came out, we've seen a whole lot of growth in F#, like when we measure internally what we can measure. And that's sort of like, there's like this steady growth, and then like it just spiked up, and it's like, like a change in the linear growth curve sort of thing. With that came a lot of open source libraries related to doing web programming and microservices oriented stuff that, kind of came out around the time that Jet was also doing this sort of stuff. So I don't know if the Jet thing is like a something that acted as like a catalyst, or if it was just sort of a coincidence. But now I think there's definitely a large cohort of F# developers who are doing primarily like web services that they deploy to some cloud somewhere. So that I think is like kind of the primary use case these days.
Would Blazor development be a good use case for F#, you think, in the future? Or WebAssembly development?
Yeah, I definitely think so. There's actually an interesting sort of, perhaps a divide in some members of the F# community on that, where some people are really into, there's this amazing technology called Fable, which translates an F# syntax tree into a JavaScript syntax tree via the Babel tool, or Babel tool. I think it's pronounced Babel. And it's all about, using F# code, sort of like a core subset of F# with NPM packages, and sort of just living in the JavaScript ecosystem. And then you can share like core domain models and algorithms with, between your JavaScript world and your .NET world. And it seems to work pretty well. Separately, the WebAssembly stuff is starting to heat up with Blazor, as you mentioned. Like, it's kind of now getting to the point where, like, us at Microsoft, we're trying to take it really seriously by building a framework on top of it, and seeing where all the holes are and trying to patch up those things so that it can become like a legitimate alternative for building web apps in the browser. Blazor itself, the programming model is interesting. So there's like the C# syntax, and that you obviously can't use F# for. But there's sort of like the next layer of like, you could think of it like the Blazor runtime that F# can plug directly into. And so that's currently being used by some folks in the community who are building a technology called Bolero. And Bolero is sort of like an alternative to Blazor, or rather it uses like Blazor infrastructure, but it's like an alternative to the Blazor programming model. And that's running 100% in WebAssembly. Right now, they actually have the F# language service itself running as a WebAssembly app on one of their demo sites. So you can compile code that runs like compiled as like WebAssembly in the browser, executing in the browser without ever hitting the network to do anything. I think it's going to be a pretty viable alternative, because honestly, I think like the promise of WebAssembly is very much, you can access this, the best cross-platform UI stack in the world, being the browser, and you get that audience, and you can have access to that ecosystem, but you don't have to deal with some of the crappier semantics that JavaScript forces you to deal with. I think that's really attractive to a lot of developers, and the fact that F# can already sort of play in that space, albeit in a slightly experimental state, but like you don't have to really go through a lot of hoops. Like the core infrastructure with Blazor, it already works with F#. I think that's pretty promising.
So how hard is it to kind of make the mental switch between something like C# to F#? Do you think of it as just a bunch of static functions, or is that wrong?
That's a good question. It depends. For some people, it's super easy. I'll use building web services as a small example. So if you think of like building a microservice or building some sort of web service, where if you think about like the HTTP interface being in terms of inputs and outputs, like, there's requests and responses, and, there's certain things that can happen in the request, certain things that can happen in the response. And if you're dealing with one of those components, that's kind of what you really care about. You generally don't really care, how the backend service is really doing anything. You just kind of care about the response that you get and dealing with, the shape of the data that you have. If you're a C# developer and you tend to, if that sort of model feels natural to you, then I would say that the jump to functional programming with F# is going to be a lot easier, because that sort of like model from a system standpoint is exactly what you deal with when you're actually writing your code. Like you layer all of your code in terms of inputs and outputs. You may have like a really huge like driver function, like, a top level driver function that accepts inputs of a certain shape and gives you outputs of a certain shape. Internally, it has a whole bunch of other sub functions, and that are all kind of composed together. And the output of one function could be the input of another, and then the output of that could be the input of another, and so on. And it tends to be pretty natural to flow into that. Now, if you are really into object-oriented programming and the design patterns around OOP, you're the kind of person who like jumps to use like the singleton pattern or the visitor pattern or something like that, I think that can be a bit more challenging to find, a mental model for in F#, because while you can do that kind of object-oriented programming in F#, because we have object support, it's not really emphasized, and it's a little bit onerous sometimes. Like it doesn't really feel right when you're doing it in the language. And so if you try to say, oh, I'm going to take this C# code and I'm going to translate it to F#, but it's super object-oriented, then I found that a lot of people sort of struggle with that transition. So I think it really comes down to like, if you have an approach for thinking about the way that your systems work that's sort of functional, then the transition's relatively simple because that just sort of comes out in the code. But if you have sort of this abstract way of thinking about your systems that's about, your objects and the relations between those objects, it can get a bit more challenging.
So do the concepts of like inheritance and polymorphism and things like that, do those still apply?
They do in a way. So like we can do inheritance in F#, for example, but it's typically very strongly discouraged. I'll give an example in terms of data types. So like one of the typical things that they teach in college with inheritance is like, you have your animal base class and there's, different types of animals that inherit from, the base animal. And, maybe there's like a feline that inherits from base animal. And then, down the chain, there's like house cat, there's tiger or something, those inherit from feline and so on. Having sort of a hierarchical approach to that is you end up kind of fighting the defaults of the language in F# when you do that. Like you can do it, but it doesn't really feel right when you're doing it. Whereas instead, you would maybe create a discriminated union type to sort of represent that sort of thing. Where you would have this class, or rather a type called an animal, and it could be a number of different cases. In functional programming concepts, they call it the sum type. Sometimes it's called a union, sometimes it's called a discriminated union, sometimes it's called a variant type. It's sort of saying that, I'm dealing with something that could be any number of cases.
Like the union type in TypeScript.
Yeah, exactly.
Yeah.
And so F# has that. So you sort of tend to model your objects as, what are called sum and product types. You have record types where you can group data together. So you say, okay, well, this conglomerate of data that I have represents a thing. And then I have other different kinds of conglomerates. And then I have a union type that sort of ties it all together, saying, oh, well, I'm dealing with either this thing or this thing or this thing or this thing. And so then you sort of have like a core data model. And then you can construct, depending on inputs to the program or something, you construct one of those cases and pass it around and deal with it. And then another component takes in, as input, one of those union types, not, a specific type, but, one of the possible cases, because, it may want to dispatch functionality based off of the shape of the data that it gets. And then so you get into this pattern matching on your data where you sort of say, oh, well, I'm not really concerned about the hierarchical structure of things. I'm more concerned with sort of the general, it's either A, B, or C sort of structure of the data, and then dispatching functionality differently based off of the kind of data that I see. It's like a subtle shift. And what usually ends up happening is you can still structure tree-like data that way. You can have, a union type where one of its cases is another union type. And within that sub-union, there's, be other unions. You could have hierarchies that are like that, but they're not tied together with like subtype polymorphism. And so this starts to get a little bit more into the sort of the underlying theory behind functional programming versus object-oriented programming, where when you're typically doing typed functional programming, like with F#, whenever you're dealing with sort of some kind of data and you want to like match on the shape of that data, you always want to account for all possible cases. And the way that the compiler actually constructs these things behind the covers is such that when you try to pattern match on the shape of your data and you don't account for all possible cases of something, the compiler will warn and it'll tell you, hey, you're not actually accounting for, this other case right here. That could indicate a program error on your part, because you can imagine your model, if you model errors as a part of your domain and you don't account for all of the errors that could occur in the flow of a program, you can take errors and you can have your core data model have errors be a part of it. Like if you're doing like a transaction of some kind, there can be all sorts of reasons why a transaction can fail. You could have that be part of the core transaction type. And every time you accept a transaction type and you say, okay, well, I'm going to do something based off of what I have, if you're not accounting for all of those error cases, then the compiler will sort of shout at you and say, hey, you got to deal with that. If you contrast that with the object-oriented inheritance sort of world, you don't actually get any help from the compiler if you're accounting for one subtype basically, but you're not accounting for all the other sorts of things. When you get into the subtype polymorphism from the compiler standpoint, it actually becomes extremely difficult for a compiler to actually, trace all the way back up and down these sort of hierarchical trees and tell you sort of if something is being accounted for or not. Whereas I guess you could say sort of like flatter structures with unions, you can, it's much easier from the compiler standpoint to be able to sort of see all the possible cases and sort of keep that resident whenever it's sort of analyzing your code and then saying, hey, we're gonna make sure that you're accounting for everything. And so that sort of like kind of gets into one of the core differences is everybody appreciates it when they get a little red squiggle in the editor letting them know that something's not going to compile, or a warning when it's like, hey, this could fail at runtime, that sort of thing. But that can only go so far with inheritance-oriented sort of type systems. But when you start getting into these more structured type systems, you can sort of lift those diagnostics a level higher, and you can represent them into your domain so that a compiler sort of acts as a tool that's sort of watching your back as you're working with this data that you're trying to model your system after.
Would you say almost that if you've been an object-oriented programmer for many years, it's almost like unwiring your brain from some of those patterns? Just because I don't use F# too much, but I remember when I picked it up, my first language when I was a kid was Pascal, procedural programming. And it almost seems like more of a flow on from that rather than going all the way to object-oriented and then trying to come back to functional.
Yeah, I'd definitely say so. There's a certain level of almost like unlearning involved. Not that the OO stuff isn't valuable. It actually is incredibly valuable. Like that's actually something that we encourage for an API design standpoint is if you use something like optional parameters and method overloading, very judiciously and very intentionally, you can have an extremely elegant API from a user standpoint. And that's super helpful. But when you start getting into this, this is sort of the core object-oriented sort of stuff, and then you try to plant that into a functional world, it doesn't really make sense. And then you have to sort of step back, as you said, sort of like rewire and go like, oh, I gotta think about how I set things up a little bit differently. And what's interesting is I've been doing a lot of, we call it customer development, where it's just a fancy word for talking to people, or where I've been talking to people who are like data scientists, or sometimes even non-programmer scientists like biologists. But increasingly in those, even in the science field, they're having to incorporate programming more and more. We've been talking to some of them, and they've sort of come and told us, from their background, they didn't learn, object-oriented programming or anything like that. When they have to use, say, like they need to do a little bit of machine learning with something like PyTorch with some Python scripts. That's a very object-oriented approach. Like the PyTorch API is super object-oriented. And they say that they struggle with that tremendously because their background is all about like, sort of like very logically structured data that's sort of like it has sort of like this enforceable structure to it. And, and then they also have a bit of a mathematics background where they just deal in terms of pure functions and inputs and outputs and things like that. And so they say, oh, I like writing functions because, I can take this equation that I know, and I can try to translate it into code, and it usually works out. And it's usually pretty easy for me to do like some modeling of stuff with something like union types. But when it starts getting into core object-oriented principles, they end up struggling a lot. And so it's something that I've been finding kind of fascinating is, on one hand, you have a whole lot of programmers learning object-oriented programming, and they step into the functional world, be it with F# or some other language, or even in their own language. And they're sort of saying, okay, you got to sort of unlearn this OO stuff and think about how you're going to do things totally differently. But then you have sort of these people who are sort of like non-programmers, or they're like secondary programmers or something like that. And they end up actually not struggling with it that much because they didn't have, they didn't have, this way of thinking that they had to sort of take a step back from and say, okay, I'm going to not sort of tread down that path when thinking about how I'm going to build my system here. And then they actually end up even struggling with that a little bit more, which I've been finding that rather interesting as I've been learning more.
One of my favorite communities in programming these days is the Angular community. Every time I go to an Angular conference or meet up with some of my friends who are in the Angular community, I have a great time. And a lot of them have wound up on Adventures in Angular. So if you're doing front-end development, you're looking for a way to keep current on the Angular ecosystem, and you want to have a good time listening to fun people talk about great topics related to Angular, then go check out Adventures in Angular at adventuresinangular.com.
I think it's a really interesting point, actually. So I think like for me, C# has always been a language that's just got a ton of features, you can do functional if you want to do functional, you can do object-oriented if you want to do that. So I've actually met like even JavaScript developers who struggle with C#, the typing system. So I always thought that F# was more of an attempt to kind of like to use less features, just to be more disciplined and focus more on like functional aspects of the language only, but are you saying it's also easy to learn, and it's more for people who aren't full-time developers and don't want to spend the time or the investment to learn C#? Do you think F# got an easier learning path or learning curve?
That's a good question. So we do have that as like a hypothesis right now. In fact, this is actually centering around something that we're working on for the Ignite conference, which is coming up in early November, so not too long from now. We're coming out with an initial preview of Jupyter Notebooks tooling for .NET, where we have sort of the shared kernel for .NET, and then we put C# and F# on top of it, and we integrate with the Jupyter ecosystem and allow you to do like inline charting and things like that. It's going after like a specific kind of person who does like analytical work, and they're a scientist or a machine learning person or something like that. We've been sort of saying like, hey, we actually think F# is capable of getting people from that world potentially more than the C# side, because while there's certainly a group of C# developers who like that interactive programming style more, and there's certainly people who do machine learning who are already familiar with C#, and so they can use it in the Jupyter environment. There's certain aspects to the language, like from frankly, all the curly braces kind of get to people sometimes, especially if they're not used to seeing all the curly braces in languages. Like if you learn like C or C++ or Java or something like that, and then you learn C#. You're like, oh yeah, this is, I'm totally used to the way this works. Braces delimit scope. It's got this, there's these semicolons. That's the end of the statement. All right, this looks all nice and familiar. But when you have these people that learned only like Python and R, like in college or something, and then they come out and then they see just sort of this, they're just awash with semicolons and braces. They go, whoa, what's all this syntactical noise? And then they got to create these things called objects, and there's these things called namespaces and classes, and you can't write any code that does anything unless you have these things. And they kind of look at it and they go, yeah, this is a little overwhelming. Whereas on the F# side, you can have just a single top level function, actually. You just write a function that takes in an input, and then you just call the function and you run the script, an F# script, and it executes in the F# interactive process, and you have it. So we have definitely seen that. I don't know if we've seen enough to sort of say definitively that like that is true, that there's these groups of people who are not traditionally software engineers who would see F# as easier to learn than C#. But we've certainly been seeing some leading indicators of that, and it's something that we're trying to explore now that we're building a Jupyter Notebook infrastructure, which is sort of a tooling that a lot of these people use in their day-to-day work.
So talking about syntax, is the syntax a lot different, or is it similar? Somebody that knows C#, would they be able to read it quickly and pick it up?
It is definitely very different. In fact, it's actually a lot more similar to Python than it is to C#. That's more of like a surface level thing, but that from a first impression, that's sort of what a lot of people say. F# is white space significant. By default, there's actually a way that you can tune it so that it's not white space significant, but people don't do that. And it uses type inference to figure things out. So a lot of times you don't see types declared up front for everything. Like you have a function and it takes in a parameter and just the name of the parameter. And you can like dot into the parameter. You can do stuff with it in the body of the function. And so a C# programmer might see that and go, but wait, what is this thing? How does it know what it is? Is it dynamic? Like, is it just magical stuff at runtime? And that's actually not what's going on. It's sort of a well-formed type inference. Well, it's called type inference the same way that C# has local type inference for var. You say var x equals something, and it's able to figure out that x is the type related to the return type of the thing that was on the right-hand side. If you sort of imagine that, but expand it out across your entire program, that's what's going on with F#. And so syntactically, that can have a really big impact, because in a massive amount of places in your code, sometimes even your entire program, you don't have to explicitly declare the type of anything anywhere. And so when you use like Visual Studio tooling, for example, you can hover over something and you'll get a tooltip that'll say, oh yeah, this is what the type actually is. Just like, if you have local type inference with C# and you hover over the name of the variable, you can see the return type for it. So we sort of extended that out, to sort of include the entirety of the language rather than just, constrained to, variables instead of the scope of a single method. And so, yeah, syntactically, it's very, very different. But there are a few conventions that look pretty familiar. So you can do things like dot into something the way that you do in C#. So, oftentimes you call a method from a NuGet package or something, right? You say the NuGet package requires you to instantiate a type, like it's or you call a method like you have newtonsoft.json, for example, the good old JSON.net, and you want to serialize some, a string as JSON. Well, you still have sort of the same code, JSON convert dot serialize objects, and then there's a parentheses, and then, a thing gets passed in there. And so I think a lot of C# programmers, when they see F# interacting with the .NET ecosystem, they'll definitely notice a lot of things that are familiar, because it's oftentimes the code looks almost identical to C# code for those sort of constrained pieces there. But then if you look at like all the code that's surrounding it, it ends up being very different.
So you're still going to get all the IntelliSense that you're used to and you like within Visual Studio to help you out with that auto completion of things.
Yes.
Okay, good.
We sort of touched on it a little bit earlier that C# is slowly adding some functional programming elements to it. With Microsoft housing sort of two very popular languages in C# and F#, we'll forget about VB for now. How closely do you guys actually work together, not just on the Visual Studio side of tooling, getting together like that, but how often do you guys come together to talk about language design? Because obviously Microsoft is in the enviable position of having two very popular languages under their roof.
So we work quite closely together. In fact, so you know how at the very beginning I said I was a part of the .NET team? One of my teammates is Mads Torgersen, who's the lead designer for C#. And so him and I, we have like a bi-weekly meeting where we chat all the time. And I'm actually also involved a little bit in the C# side. So by the way, if you're using nullable reference types in C#8, I can definitely, help you out with some of that stuff, because I'm definitely involved in that. So there's a lot of cross collaboration there. Just like on the C# side, we try to document our designs a lot, and we have it open up on GitHub. So a lot of times, it's not even necessary to sort of try to find someone in the office and be like, hey, tell me about how this thing works, because, we try to make it very clear what we were doing and why and what our goals were, what the actual design of things were. And so oftentimes they can say, oh, hey, we took a look at the design of this thing, and, let's have a talk about, what that means for C#, because we're going to have to tweak it for C#. Like we can't just straight up, take something that F# has and make it work in C#. That actually never actually even ends up working out because of some of the fundamental differences in the language. But so once they sort of said, okay, well, we have sort of a design that we think makes sense for C# programmers. Let's talk about how we can design the way that C# and F# talk to each other with this thing. That's where a lot of the collaboration comes in, because we have this really core tenet of, it's all .NET at the end of the day. And we want to have C# and F# interoperate as best as they can. So a good example of this actually operating in the reverse is the span support in .NET Core. So span, for those who aren't necessarily familiar with it, is a sort of like a new performance primitive type that exists in .NET Core. And fundamentally, it's a pointer and an offset that sort of represents a region in memory. But what's important is a span is a type of struct that we call a biref-like struct. And a biref-like struct has a couple of invariants about it, namely that it can only live on the stack. It can never be allocated on the managed heap. And so the runtime, when it sees that, it's able to apply a couple of performance optimizations that you would not be able to guarantee with normal structs. And so if you write code that uses span as sort of the primitive, you can get like really, really great performance where you basically allocate nothing and everything ends up running a lot faster because of that. This core design for all of this sort of stemmed from the C# side, because there were a lot of people, like especially in the Unity world, where they wanted to write high performance code, but they wanted to have, they didn't want to drop into C++ for that. They wanted to, use a managed language and get really nice tooling and, a lot of other guarantees that you get when you have a managed language. So on the C# side, they also designed a lot of semantics around how you can use types like this in the flow of your code. Like, there's a lot of very strict rules about how you can instantiate one of these things and how you can call them and how you can pass them around. So there was a lot of collaboration between us and them on sort of saying, hey, let's take a look at those sets of semantics. And then on the F# side, we're going to apply as many of them as make sense. And we're also going to add our own based off of some unique aspects of the F# language. That sort of thing happens all the time. And it's something that's happening, especially now with the forthcoming, I guess it's not guaranteed that it's going to land in C# 9, but there's been a lot of design work in record types for C#. And F# already has record types. But in C#, they're going to be kind of different. They're not going to be like record types as you would know them if you were an F# programmer. But they took a lot of the core designs that we had, especially about how F# records generate, default equality and hashing for you, so you don't have to, override any of these methods. You can just get structural equality and just compare things, and everything just works out. They said that is a really elegant design that we're going to try to make also work for the C# records. And then we're going to work together to sort of figure out how the interoperation story works out. So that in F# you can consume a C# record, and in C# you can consume an F# record and still get the same program semantics, the same semantics in like the host program that you're writing.
So there are some aspects of like F# that are fundamentally different. Like I was thinking about, I just did some reading before, and I could be completely wrong because I've only done reading on it. But with the discriminated union types, you can return two different types. Is that right? Based on the logic, right?
You could view it as sort of like this tree that the compiler knows statically. Yeah. Like, there's sort of this root, which is, the name of the type, and it could be any number of these cases that you have there. And so, yeah, sort of depending on what you do, you can sort of say, oh, well, I'm going to return this case versus this other case.
If a C# method is attempting to consume an F# discriminated union type, what would it see? What would it expect it to return?
So under the covers, that type right there actually gets turned into a sealed class with a bunch of other subclasses in it. And so from the C# side, you then, when you're working with one of those specific cases, you see it as that sort of class type that's one of those cases. But then you can't, do anything with it. It's a closed hierarchy at that point from the C# side. And so that's sort of how we end up emitting it. And the reason why we do that is because that's the, objects is sort of like the lingua franca for C# really, about how things communicate with each other. So that's sort of how you do that. Though I would definitely say that typical patterns, the typical interoperation pattern is, especially when you're working with DUs, like you can consume them in the C# side, but a lot of people usually end up wrapping, they have like their core logic that works in terms of these unions. And then they emit their own object type that, tries to represent the domain in a very C# friendly space. So they sort of have their layer their code where they have like an interop layer, and they say, okay, the core logic does its thing, shoots back up to the interop layer, and then we construct one of those objects and we hand it off to the C# caller. Mm. Yeah, it's like if you wanted to certainly interoperate with, those custom, well, I shouldn't say it, but those F# types like records and DUs, like they do sort of get emitted as classes that the C# side can deal with.
So we just got up to C# 8. And what's the latest version of F# and what's coming next?
Yeah. So the latest version of F# is F# 4.7. We came out with that in conjunction with C# 8. It's kind of interesting. Between C# 7 and C# 8, so there was C# 7, 7.1, 7.2, and 7.3. C# had these point releases, and then it had no releases for a long time, and then C# 8. During that point release time, we had no releases for F#, but then we had F# 4.1, and then we did an F# 4.5 where we had to skip some numbers because of like a versioning alignment with like core library thing, and we got rid of a bunch of legacy like versioning annoyances that people had. But then between F# 4.5 and 4.7, we shipped a 4. We did the 4.5 and then the 4.6 and then the 4.7. And so, although F# 4.7, it's like a minor release, we have a few features like implicit yields in certain expressions, which is kind of more of a, I like to think the theme of F# 4.7 is just kind of being about like cleaning up some more onerous patterns that you have to do in F# today. It's really sort of like the end of like a family of releases, new primitive types, a new type with anonymous records that has, some subtly different things that you can do compared with normal records, a whole bunch of core library fixes, a whole bunch of, static analysis that we have in the compiler, a whole bunch of performance fixes, and now a whole bunch of things that kind of clean up little syntactical quirks that have lived in the language for a long time. And that's sort of what F# 4.7 is all about, is sort of the culmination of that sort of stuff over the past year and a half or so of releases. And so what's coming next is it actually relates to F# 4.7, because one of the things that we did is we shipped support for language version, meaning that you can toggle in your project file. You can say, oh, I want my effective language version for F# to be preview rather than F# 4.7. And then we shipped 2 additional features in preview form, being the name of keyword and opening of static classes. Again, a lot of that is sort of like, general niceties and interoperation with certain parts of the .NET ecosystem was sort of the motivation behind that. What's coming next is F# 5, which we're going to align with the .NET 5 release next year. We're aiming for next year, November timeframe for that. And we're going to have, F# 5, .NET 5, try to align the numbers all nice. One of our plans is .NET 5 is going to have a monthly preview cadence where sort of, once we come out with the first preview of .NET 5, the next month is going to have another preview and another preview and so on. And we're aligning the F# 5 ship cycle with that so that, there's going to be a corresponding preview of the F# 5 language with the .NET 5 previews. And every time that rolls around, we're hoping to have a new feature kind of ready to go that people can try out and, let us know about the design of. So we're really excited about this because previously we didn't really have the infrastructure to be able to ship preview features alongside release features inside of a released compiler. And now that we do, these people who want to try out new stuff, they don't have to go and get a custom build of the compiler from our GitHub repository. They can actually use the released compiler that we ship inside of Visual Studio and just turn it on into preview mode. And all of a sudden they get some new stuff. That's something that we're super excited about. And we have sort of a lot of different features sort of lined up, or I guess I should say candidate features that we're kind of working on right now. And as they stabilize and start to get to the point where we think the core design is good and we think it's stable, but we want feedback on it, we'll get it out as a preview in the next release of the F# compiler and try to get feedback from users.
Nice. So is there anything else that we haven't covered today that you wanted to let the listeners know about?
No, I'd say sort of the main thing is maybe on the getting started side for F#. Like, if you're listening to this podcast, you're a C# programmer and you said, all right, I'm going to take the jump. I want to learn some F# and functional programming and just try to warp my mind a little bit. No guarantees if I transition fully into an F# programmer or something, but just, try something different. It really is as easy as just downloading the .NET Core SDK, or if you're a Visual Studio user, it actually already comes by default. So you should already see it in the new project templates. So if you're on a Mac or you're not using Visual Studio on Windows, all you have to do is download the .NET Core SDK, just the latest .NET Core that includes the compilers, the core library, and build tooling that works with F#. And then if you want to use something like Visual Studio Code, you can install a plugin called Ionide, which has, I think now it's a little over 1.4 million downloads. It's a community project that uses the same F# compiler tooling that Visual Studio does. In fact, we actually worked with them to stabilize a lot of the plugins so that you can use it for real-world development. You can do cross-platform F# development without even needing, a Windows machine or Visual Studio to do that. But if you are, at home in Visual Studio, you can just go to, File New Project, and there's like a little language drop down, and you can select F# from there. And there's a couple project templates. You can kind of get going from there. Yeah, I definitely encourage people to try it out because we love seeing more F# programmers. And I think it's also one of the reasons why I also really like it, aside from the fact that I work on it and I like more people using it, is I like the idea of programmers, trying to expand their minds a little bit and trying out new ways to think about problems. Even if they come back from it and say, yeah, I'm not really going to use this, it can still be valuable because, they were introduced to a different way of thinking about things. And so I'm really happy that you can do that with F# without needing to set up a whole bunch of stuff and waste like a couple hours trying to even write your first line of code. So,
okay. So where should somebody go to start learning? So is there some good documentation or tutorials out there for somebody to get started with?
So I'd say there's 3 concrete resources. The first is it relates to the getting started link, but we also have a short tutorial there. We have a short link called aka.ms/f#home. It's sort of like an F# homepage on the .NET site. There's like a little get started button, and then we have like a short tutorial that shows you how to build a console app, write a function that the main function calls, and prints out like a neat little thingy. Then from there, that breadcrumbs into some links to the official F# docs, where we have a few tutorials and sort of a reference of various parts of the language if you want to deep dive into anything. So that's sort of the second one, is the F# docs. And then the third is a really wonderful website built by the community called F# for Fun and Profit. The site has like a series for learning F# if you're already a C# programmer, or like if you're already an existing C# or Python programmer, I believe they call it, where they basically, like, the whole pitch of it is like, hey, here's a problem. Here's how you would think about it in C# world. Here's how you would think about it in F# world. Let's talk about those differences. A lot of F# programmers who came from C# use the F# for Front and Profit site as sort of their first step into it. And so I definitely recommend it. Like, once you've gotten, probably the best way to start is with the F# homepage, because that just like gets you to like the very basics of, you build a console app that calls a function so that you know how that whole thing works out. And then, maybe you go to the F# docs, you see a little bit of code that shows you how to write a few things a little differently. And then I would really recommend getting into F# for Fun and Profit. That's where it sort of gets you into the core, hey, here's how you can take the existing skills that you have and, morph them a little bit into something that'll work in the F# space.
And for those links, that's sharp spelt out, right? Not the pound sign. Yeah. So FSHARP home.
Yeah, absolutely.
Yeah. Okay, good.
One of the things that I have as a goal for devchat.tv is to cover technologies that are up and coming, things that we're probably going to have to deal with on a more regular basis in the future. Some of these include AI, VR, and one of them is blockchain. So I reached out to one of the experts that I knew, Gregory McCubbin, and we pulled together a few other people, and we've started a podcast called Adventures in Blockchain. So if you're looking at blockchain as something that you may want to work in, something that you're curious about learning more about, or something that you just want to keep current on until you have the opportunity to make a career jump and go over and work in blockchain and crypto, then definitely check out Adventures in Blockchain. You can find it at adventuresinblockchain.io.
So the last thing we want to do is go through picks for each of us. So if you don't have one, you can try to think of one real quick. I'll get it started. And my pick this week is the blogs by John Skeet. So if you don't know who John Skeet is, he's somebody that's got a 1.1 million plus reputation on Stack Overflow. So he's been around for a while. He's definitely well known. So if you don't know him, check out his blog. He's got lots of interesting posts, some good ones out there now on C#8. And he also has some posts on F#. So check it out.
Cool. I'll go next. So I'm going to have a link for actually a link I saw on Hacker News just the other week, and it's called TimSort, the fastest sorting algorithm you've never heard of. And it's actually the default sorting algorithm for Python, and I think actually a couple of other languages. And it's a sorting algorithm that is sort of adaptive to the array size. So if it's less than 64 items, it'll sort a certain way. When it's more than that, it'll sort a different way. It'll look into the array and check if it's got these things called runs, and it will sort it a certain way if it's like that. It's a really interesting read on how the default sorting works in Python and a couple of other languages. So I'll chuck that in.
Okay, so my shot. So this week I chose a product called 97 Loft. It's basically like, it's for the Google Home, and I've got a Google Home. It's pretty good. Kids always try to mess around with the different commands and stuff, but the only problem is it's like there's no battery, so you can't take it anywhere. With this 97 Loft, it's basically like a battery base that you attach to the bottom of the Google Home, and so that now I can just if the kids are in the backyard of it, I can just take the Google Home and take it to the backyard and walk around the house with it, and chuck music on wherever I go. So yeah, it's for me, it's made the Google Home a lot more useful.
Nice. Yeah, I've got a Google Home too, so I'll have to check that out. Okay. So Philip, have you thought of something?
Yeah, I'll definitely go. I pasted a link in the chat there, but I also have the hard copy. This is the 100-page machine learning book. It's short, right? But it's actually super dense. But it's good.
Yeah, so how small is that print?
Yeah, I recommend it if you have a bit of a background in math. You need a little bit of a background in math, honestly, but you can also look a lot of stuff up as you go. But I've definitely been enjoying reading it as I've been wanting to dive more into machine learning, because I didn't study it when I went to college, but it's becoming increasingly important in our industry to sort of understand a lot of the concepts. And this book is all about explaining the concepts like in depth and not necessarily diving into all sorts of super specific things. It's all about, here's all the different algorithm types, why they matter, some general applications for how you can use them. And they kind of go into graphical representations of results and, how you could think about problems in that way. And I've really been enjoying it. So I definitely recommend people who are looking to sort of dive into the space and try to get a better understanding of machine learning to pick it up. And I think it really lives up to its name. Like it's basically 100 pages of like super core fundamental concepts that it just dives into. And it's pretty great.
Great. Well, it was really nice having you join us today and talk about F#. Hopefully we can really expand the community and get more people involved with F#. So really, thanks for taking the time with us.
Yeah, no, thanks for having me. This was a lot of fun.
Okay. We'll see everybody next time.
Cool. See you later, guys.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.